Maupay nga adlaw sa iyong atanan. Welcome to Engineering e-Learning Channel. Our topic for today, for Simplified Integral Calculus, under Unit 2, Integration Technique, Integration by Partial Fraction. A fraction in which the numerator and the denominator are each a polynomial in one variable where the degree of the numerator is less than the degree of the denominator is called a proper rational fraction. If such fraction cannot be integrated, we have four conditions. Let's start with condition 1. Fraction with distinct linear factors in the denominator. We have this one as condition 1. What do we have in condition 1? Case 1, fraction with distinct linear factors in the denominator. For each linear factor, ax plus b in the denominator will be a partial fraction, a all over ax plus b. There will be each partial fraction will have each factor as a denominator. Moving on to your first example for your case 1. For your example number 1 for case 1, example number 30, evaluate the integral of 3x squared plus 32x minus 51 all over the quantity x minus 1, x minus 2, and x plus 3. Okay, so what is our first step? If we observe our denominator, it's composed of three quantities. These factors in the denominator will tell you the number of partial fraction there will be. So there are 3. So it means that there are 3 partial fraction. Okay, for our solution, we need to resolve this function integrand into partial function, partial fraction. So we need to simplify the given problem. So we rewrite. Okay, the integral of 3x squared plus 32x minus 51 all over x minus 1, x minus 2, x plus 3. So observe that there are 3 quantity for your denominator. It means that there are 3 partial fraction. Okay, we rewrite it into partial fraction. Is equal to a over x minus 1 plus b x minus 2 plus c x plus 3. Okay, so we need to simplify the equation with respect to its LCD. So if we rewrite 3x squared plus 32x minus 51 is equal to a. So the technique, if you are writing your a, you only copy b and c. If you are writing b, you only copy a and c. And if you're writing for C, you only copy B and A. So that's how we write our partial fraction when we simplify the LCD. So A, we only copy x minus 2 and x plus 3. X minus 2, x plus 3. Okay, plus B. So we copy the adjacent x minus 1, x plus 3. Okay, plus C, we copy A and B. So x minus 1, x minus 2. Okay, now that we're done with our equation, so this is our equation 1, we assume value for our x. We assume value to make sum of the terms equal to 0. So if we let when x is equal to 1, okay, if we rewrite, we need to solve the terms with respect to A only. Okay? So we have 3x squared plus 32x minus 51 equal to A, x minus 2, x plus 3. So what is the value of our A if our x is equal to 1? So we simply substitute the value of 1 to x plus 32, 1 minus 5 is equal to A, 1 minus 2, 1 plus 3. Okay. Therefore, if we continue the process, A will be 4. Okay, we already have a value of our A. Moving on to the next, x is equal to 2. So we solve in terms of B. Still copy the 3x squared plus 32x minus 5 is equal to B, x minus 1, x plus 3. Okay, we substitute the value of x, which is 2 squared plus 32 times 2 minus 5, that is B, 2 minus 1, 2 plus 3. So if we continue, our B will be 5. So that is your B. Let's continue. Let's solve for our C with respect to the term C with the value of negative 3. Where did the negative 1 came from? If we equate this to 0, this will be 1. If we equate this to 0, this will be 2. If we equate this for 0, it will be negative 3. So same with our value of our x when we assume. So when x is equal to negative 3, so let's copy the equation, 3x squared plus 32x minus 5 is equal to C, x minus 1, x minus 2. Substitute the value of x, negative 3, 3 squared plus 32 negative 3 minus 5 equal to C, negative 3, negative 3 minus 1, negative 3 minus 2. If we continue, our C will be negative 6. So we already have values for our ABC. Okay, so we rewrite our function. Okay, we rewrite our function. We substitute the value of our A, B, and C to our partial fraction decomposition. So we can integrate. So this is, I write it on top. Integral bracket your A 4 all over x minus 1 plus your B is 5 x minus 2 plus your C negative 6 x plus 3 close the bracket dx. So now we can do our integration. We apply our property number 1. We distribute the integrand and dx inside this bracket. So that is integral and also 1 and 2. Property 1 and 2. So we carry out real number constant and we distribute the integrand inside the bracket. So that is 4 dx over x minus 1 plus 5 integral of dx x minus 2 negative times positive negative okay, we carry out still the real number constant 6, so negative 6 integral of dx over x plus 3. Okay, so what is our next step? We apply our logarithmic formula. Logarithmic formula number 3. What is our logarithmic formula? The integral of du is equal to u is equal to ln u plus c. Okay, if we apply our logarithmic number 3 formula, that would be 4 ln x minus 1 plus 5 ln x minus 2 minus 6 ln x plus 3. Of course, your constant, your arbitrary constant. Or by applying the exponential law or logarithmic law, we can combine all the logarithmic, okay, transposing its base as its power. So if we do so, negative, so our ln, so we apply our logarithmic law. Okay, so this is x minus 1, the base become its power. Here's the same also, the base become its power, x minus 2 to the 5th, and the negative as your denominator. So ln, no, that is quantity x plus 3 only. X because you have already the ln, x plus 3 and its power 6. Of course, your arbitrary constant. So that is your final answer for example number 30, which can be found in your workbook on page 109. For question, comment down below or send your message to our GC. Okay, moving on to your next example. Okay, for your next example, Still, under case number 1, example number 31, evaluate the integral of x squared minus 2x plus 3 all over x, quantity x minus 1 times quantity x plus 2 dx. So, okay. So, our denominator tells you how many partial fraction there will be. Okay, so we have 3 x minus 1, and x plus 3. So there are 3 partial fraction. So we need to resolve this integrand into partial fraction format. So for your solution, okay, so we rewrite the integral of x squared minus 2x plus 3 all over x, quantity x minus 1, quantity x plus 2. So if we rewrite, this a, so 3 partial fraction x plus b, x minus 1 plus c, x plus 2. Again, so we rewrite this function into LCD format. So x squared minus 2x plus 3 is equal to, again, if you're writing for your a, you'll copy b and c only. If you're writing for your b, you'll copy a and c only. If you're writing for your c, you'll copy a and b only. Okay. Writing it down, that would be a quantity x minus 1, x plus 2, plus b, x plus 2, plus c, x minus 1. Okay, so I hope it's clear. So we have an equation. Now we solve for your a. We assume value. When your x is equal to 0, we solve for your a only. So x squared minus 2x plus 3 is equal to a, x minus 1, x plus 2. So if our x is 0, that's 0 minus 2 times 0 plus 3, a 0 minus 1, 0 plus 2. Okay, so the value for our a, if we continue solving for the unknown, a is equal to negative 3 halves. So that is your a. Okay, so that is here. Since we have no constant, we assume 0. So for your b, so when x is equal to 1, again, we equate x minus 1 to 0, so it become 1. So rewriting x squared minus 2x plus 3 is equal to b, x plus 2. So if our x is equal to 1, we substitute the value of our x. 2 times 1 plus 3 is equal to b, 1 plus 2. Okay, solving for your b will become 2/3. Okay, continue. For our c, what that is, we transpose 2, it becomes negative 2. So when our x is negative 2, x squared minus 2x plus 3 is equal to c, x minus 1. We substitute the value, negative 2. Negative 2 squared minus 2 times negative 2 plus 3 is equal to c, negative 2 times negative 2 minus 1. So solving for your c, that is equal to 11 over 6. So we have the value for a and b and c. Now we can substitute it to our partial fraction decomposition format. Okay, So that is the integral bracket. So what is the value of our a? That is negative 3 halves all over x plus about for your v, that is 2/3 x minus 1. How about for your c? 11 over 6 x plus 2. Those are bracket dx. So we can simply integrate the function. Applying some of our properties, property 1 and 2, it become negative 3 halves integral of dx over x plus 2/3 integral of dx x minus 1 plus 11 over 6 integral of dx x plus 2. Okay, so applying again our logarithmic formula. Logarithmic formula number 3. That the integral of du over u is equal to ln u plus c. Okay, we apply negative 3 over 2 ln of x plus 2/3 ln of x minus 1 plus 11 over 6 ln x plus 2, and of course your arbitrary constant c. So that is your final answer for your example number 31. Can be found on your workbook page 110. You can still rewrite it into our logarithmic form. Okay? For question, comment down below or send your message to our GC. Moving on to our next example, so we'll be discussing case number 2 sample problem. Okay. Okay, case number 2. Fraction with repeated factors in the denominator. For each repeated linear ax plus b raised to k, of the denominator, there will be k partial fraction form. So when the numerator a and b and k are constant, it means that whatever the value of your power k, that will be the number of partial fraction we'll be having. Okay, so let's have an example. Example number 32. Evaluate the integral of 2x plus 1 all over quantity x minus 2, x minus 3 squared. So if we observe, we have a power of 2 and 1. So we have 3. So it means that we have 3 partial fraction. Rewriting our function into partial fraction form, that is 2x plus 1 all over x minus 1, x minus 3 squared. So we rewrite in our partial fraction, that is a x minus 2 plus b x minus 3 plus c x minus 3 squared. Okay, so if we rewrite it with respect to its LCD, that is 2x plus 1 equal to your a. So for your a, if you're writing for your a, you will only copy the what? The c only. Why? This is only a dummy that is equal to 0. Okay, so a x minus 3 squared. How about for b? Of course, you'll copy both. That is b. If you're writing for your b, your copy your A and B. Okay, so that is x minus 2, x minus 3. How about for your C? If you're writing for your C, you'll copy only the A. Since B is a dummy of your C, you only copy the real A. So that is C, x minus 2. So we have an equation. We have a values to assume. So first we start with, if we equate to 0, we have 1 and 3 from the function, from your denominator. Okay, so when x is equal to 1, we can determine A. So that's 2x plus 1 is equal to A, x minus 3 squared. So if we substitute the value of our x, that is 2 times 1 plus 1 is equal to A, 1 minus 3 squared. Solving for your A, you have the value of 5 for your A. Next is our 3 squared. So we start with C. So A, C. So when our x is negative equate to 0, that will become positive 3. So we can solve for our C. That is 2x plus 1 is equal to z, x minus 2. So if we substitute the value of our x, this is 3, 2x plus 1, c, 3 minus 2. Solving for your c, that is equal to 7. So we already have value of our A and B. Now we determine our B. Since our B, the denominator is only a dummy from your quantity x3 squared, so we assume the value for B as 0. So when x is equal to 0, we can determine our B. So 2x plus 1 is equal to B. What is our B? That is x. Sorry. That is B, x minus 2, x minus 3. Okay, substituting the value of your x, which is 0, that is 2, 0 plus 1 equal to B, 0 minus 2, 0 minus 3. Okay, solving for your B, you can have negative 5. Okay, we already have value for your A, B, and C. Now, we can rewrite our partial fraction. That's integral of bracket A, 5 x minus 2 plus your B, negative 5 x minus 3 plus your C, 7 all over x minus 3 squared. So we can solve for our term A and B dx, but for our C, we can use our power formula since it involved power. Here, we can use our logarithmic formula number 3 right away. So using our logarithmic formula number 3, the integral of du over u is equal to ln u plus c. So we can integrate this right away. But first, we need to apply property number 1 and 2, carry out real number constant, and distribute the integrand and dx inside the bracket. So doing so, we can write it is your 5 ln x minus 2. Negative times positive, negative, it will become negative. That is 5 ln x minus 3. How about here? If we apply property number 1 and 2, we carry out real number constant. Yes, we carry out real number constant, integral of dx over x minus 3 squared. Or we can rewrite this to a different form, that is 7 integral of x minus 3 negative 2. So since it's from denominator, we put it in numerator, the power become negative. Here we can apply our power formula. So what is our power formula? That is integral of u raised to n du is equal to un plus 1 all over n plus 1 plus c. Okay, writing it down. Plus c, quantity, x minus 3, negative 2 plus 1 all over negative 2 plus 1 plus c. It will become 7. It's still negative. The remaining is x minus 3, that is negative 1. Here also negative 1. So none. So we only consider negative. So that is negative 1 times positive 7. It will become negative 7. So writing your power become x minus 3 raised to negative 1. Of course, plus your arbitrary constant. And copying the other values for your a and b, that is 5 ln quantity x minus 2 minus 5 ln quantity x minus 3. So this is your final answer for your example number 32. Okay, so moving on to your next example. Okay, for your second example, for case number 2, we have example number 33. Evaluate the integral of x squared plus x minus 4 all over quantity x minus 1 squared, quantity x plus 3 squared. Again, check the denominator. So we have a power of 2 and 2 square. So sum of 4. Therefore, we have 4 partial fraction decomposition. So rewriting our function, that is x squared plus x minus 4 all over quantity x minus 1 squared, x plus 3 squared. So observing the power, it means that you're going to use this x minus 1 twice and x plus 3 twice for you to have a 4 partial fraction decomposition. So rewriting your partial fraction, that is your a, x minus 1. So we use it 1. Second, b, the same, x minus 1 squared. Plus your c, you're going to use x plus 3. So we use the other one. And for your d, that is x plus 3 squared. Okay, so we rewrite this. So we can have, with respect to the LCD, x squared plus x minus 4. Again, if you're writing for your a, you'll only copy itself here and the d. If you are writing for your b, you'll copy what? D only. If you're writing for your c, you'll copy b and itself only. How about for your d? Same as b, you'll copy itself only. Okay, so I hope it's clear. So rewriting a you'll copy x minus 1 and x plus 3 squared. How about for your b? You'll copy the d only. That is x plus 3 squared. How about for your c? You'll copy the b, x minus 1 squared, and x itself, x plus 3 only. How about for your d? You'll copy it's the a only. So that is x minus 1. So for your d. Okay, moving on. Correction, that should be b only for your d. Also correction, okay? If you're writing for your d, you're only copy the b. Okay, so we assume values. We start with it. So if we keep this to 0, this will become positive 1 and this will become negative 3. Okay, so we'll start with the value of our x is equal to 1. So here, we can solve for our b. Okay? So x minus 1 squared, x minus 1 squared. So start with b. If you observe, if we use this x squared, so we start with our b to determine. So that is x squared plus x minus 4 is equal to b. That is x plus 3 squared. So if we substitute the value of our x, which is 1, 1 squared plus 1 minus 4, and b 1 plus 3 squared. So solving for it, you have b negative 1/8. Okay, next is 3. So we equate to 0, it will become negative 3. So if our x is equal to negative 3, so x plus 3 power squared, so we start with letter D. Okay, if you notice, there is a pattern, okay? So x squared plus 4, no. That is x squared plus x minus 4 are d x minus 1 squared. If we substitute the value of our x, which is negative 3, that is negative 3 squared, negative 3 minus 4, d negative 3 minus 1 squared. Solving for your d, you can have 1 of 6. 1/6. Or, correction, 3 squared minus 3, that is 9, 4. Okay, that is 16, 2 of 16. We can write it to half of 16, that is 8. Okay, so D is 1 over 8. Okay, so our next move is to determine our B and C, which is only the replica of our function. So we assume value of what? 0 na. Okay, so if we assume x is equal to 0, we can determine for your B and C. Since we have the value of our B and we have the value of our D, we can determine our what? Equation A. So we can determine our A. So if we assume x is 0, we can have an equation with respect to B and C, the remaining. Since we substitute the value of our B and D, so the remaining is C and A. So that is an equation. We still need to manipulate algebraically. Go. If it is x is 0, So for b, maybe we start with our, okay, so start with 0. X squared plus x minus 4. So the remaining, we copy all of them. So a, x minus 1, x plus 3 squared plus b, x plus 3 squared plus c, x minus 1 squared, x plus 3 plus d, x minus 1 squared. So of course we substitute the our b and d to the equation and apply x as 0. If we do so, okay, the result will be negative 4, negative 9a plus 9b plus 3c plus d. But we have a value already for our b and d. Okay, so our equation, we can determine our c here. So we can say that our c is equal to 3a minus 1. So let's assume this as your equation 1. Okay, we have x is 0. So what's next? Of course, negative 1 is the next. Okay, the same. If we copy, x squared plus x minus 4 is equal to a, x minus 1, x plus 3 squared plus b, x plus 3 squared plus c, x minus 1 squared, x plus 3 plus d, x minus 1 squared. So we substitute the values. We can have negative 4, 8a plus 4b plus 8c plus 4d. Again, we substitute the value of our d and b. So we can have our equation 2. So we can say that our equation 2 is equal to 1 is equal to 2a minus 2c. Since you have a value of your b and d, so a and c is the remaining. So we can say that this is our equation 2. You have a c, you can substitute it to your equation 2. Okay, so it is clear. So if we substitute equation 1 to equation 2, we can determine, okay, for example, we have 1 equal to 2a minus 2c. Our c is equal to 3a. So 2a minus 2, 3a minus 1. So finally, our a, it's, if we solve, 6, 2, 4, that is 1 over 4. You solve it algebraically only. So if you have a value of a, substitute it back to your c. So you can have value for your c. If you do so, that is c 3a minus 1, say 3 times 1/4 minus 1. So finally, your c is equal to negative 1/4. Okay, we have a value for b, we have a value for d, a, and c. Now, we can write our partial fraction decomposition. If we rewrite our partial fraction decomposition, integral of x squared plus x minus 4 all over x minus 1 squared quantity x plus 3 squared. Writing our partial decomposition, that is integral bracket a x minus 1 plus b x minus 1 squared plus c, x plus 3 plus d, x plus 3 squared, or dx. Okay, substituting the values, that is 1/4 x minus 1 plus rb, that is negative 1/8 x minus 1 squared, c, that is negative 1/4 x plus 3 plus your d, that is 1/8 x plus 3 squared. Okay, same process for your term A, for your term B and term D. For your term B and D, you can use your power formula. How about for your A and C? Of course, you can use your logarithmic formula. For A and C, you can use logarithmic formula. That is integral logarithmic formula. The integral of u du over u, that is ln u plus c. How about for your B and D? You can use your power formula since it involves powers. So you can integral of u raised to n du, that is u n plus 1 over n plus 1 plus c. Okay, doing it and writing right away. That is 1/4 ln x minus 1 plus, if you have a power, that is negative, and here if this will be transposed to the numerator, it will become negative 2, so it will be negative, so negative cancel out, it's still positive, so we carry out positive 8 and we rewrite it its power, so it become your x minus 1. How about here? So still negative, so you apply your logarithmic formula, ln x plus 3. How about here? So it's power formula, so it become positive, so here if you transpose it to the numerator, it becomes negative, so plus 1 plus 1, it's still negative 1, so negative times 1/8 is still negative, that is negative 1/8. So we copy the denominator x plus 3. Of course, your constant plus c. Okay, so we can simplify here. We combine logarithmic, we combine the two power. Doing it, we have a common of 1/4 ln negative, so x minus 1 and the base x plus 3 plus, how about this 2? It become x plus 3 minus x minus 1 all over 8 x minus 1 x plus 3. Okay, so we write our final answer. That is 1/4 ln x minus 1 x plus 3 plus 4 here, 8 x minus 1 x plus 3 plus c, so we cancel our 4, so it is your final answer 1/4 ln x minus 1 x plus 3 plus 1 2 x minus 1 x plus 3. Okay, so that is your final answer. You can simply it further, okay, if you want. So this is your final answer for your second example for case number 2. For question, comment down below or send your message to our GC, or you can personally send your message to your Moodle account. Okay, so that would be all for today. Thank you for your time and have a nice day, everyone.